Let us see the first type of scene, which is geometry scene. We can create a geometry scene to view outlines and surfaces of parts in the simulation. Along with the geometry scene, some basic entities are also created. A geometry displayer. This contains all boundaries in the simulation and is preset to display the outlines of the parts. A second geometry displayer. This contains all boundary parts in the simulation and is preset to display the shaded surface. To create a geometry scene, right-click the Scenes node, select New Scene and then Geometry from the pop-up menu. Let us see the mesh scene now. We can create a mesh scene to view the mesh grid along with surfaces of parts in the simulation. Basic entities that come with mesh scene are a geometry displayer. This contains all boundaries in the simulation and is preset to display the outlines of the parts. A second geometry displayer. This contains all boundary parts in a simulation and is preset to display the mesh cells on the shaded surface. To create a mesh scene, right-click the Scenes node, select New Scene, then Mesh from the pop-up menu. Next is Scalar Scene. We can create a scalar scene to view scalar contours on parts. We can choose to view contours of any scalar field function. Along with the scalar scene, the basic entities that are created are a geometry displayer. This contains all boundaries in the simulation and is preset to display the outlines of the parts. A scalar displayer. This contains an undefined scalar field and no parts. We can add any valid part on which you wish to see scalar data. For a two-dimensional simulation, all region parts are added to the displayer by default. To create a scalar scene, right-click the Scenes node, select New Scene, then Scalar from the pop-up menu. Now, let us see the vector scene. We can create a vector scene to visualize the velocity field on parts. We can choose to view glyphs of any vector field function. When you create a vector scene, two displayers are created. 1. A geometry displayer. This contains all boundaries in the simulation and is preset to display the outlines of the parts. 2. A vector displayer. This contains a vector field with no parts. You can add any valid part on which you wish to see the vector data. For a two-dimensional simulation, all region parts are added to the displayer by default. To create a vector scene, right-click the Scenes node, select New Scene, then Vector from the pop-up menu. Last is the empty scene. It is a blank canvas on which we can add any type of displayer. Each new displayer contains no parts and is set to the default settings. Also, we can add parts directly using the drag and drop technique. To create a new empty scene, right-click the Scenes node, select New Scene, then Empty from the pop-up menu. We have talked about the displayer a lot. Let us see in detail what a displayer is. A displayer is the basic building block used to build a scene. It provides a flexible way of defining and controlling the graphics entities appearing in a scene. There are 4 types of displayers available in *CCM+. 1. A part displayer to control the appearance of geometry. 2. A scalar displayer to control the appearance of scalar contours. 3. A vector displayer to control the appearance of vector glyphs. 4. A streamline displayer to control the appearance of streamlines. What does a displayer consist of? It consists of one or more parts, an attribute such as scalar or vector field, surface lighting, color, opacity, normals for smooth shading, and transforms. A displayer takes these parts and attributes and produces the appropriate graphics entities to represent the parts in the scene. Let us now see the mesh displayer. We can display the mesh on the surface of any part in a geometry displayer. Expand the Scenes node and expand any scene that includes a geometry displayer. This can be any default geometry, scalar or vector scene, or an empty scene in which we create a geometry displayer. Expand the Displayers node and select the Geometry Displayer node. The Display Mesh property of the Scalar Displayer works in the same way. In addition to displaying the mesh outlines, the surfaces of each cell may be illustrated by shrinking each surface element. For this, make sure that the surface is visible. To shrink the elements, click the right column of the Element Shrink property in the Properties window. In the slider box that appears, select a value between 0 and 1, where 0 results in no surface and 1 results in whole surface elements. We can also enter our selection directly in the value text box above the slider. Then, click anywhere in the workspace around the slider box to close it. What are scalar displayers? Scalar displayers are used to display scalar field functions or field function monitors on parts using contours. The Scalar Displayer node controls the display of data along the surface of a part. A scalar displayer is created automatically when a scalar scene is created. We can add a scalar displayer to any scene. For this, open the Scenes node. Then, open Node of the chosen scene. Right-click the Displayers node and select New Displayer. Then, select Scalar. By default, the Scalar Displayer will contain no parts after creation, and we must add parts to the displayer. Next comes the Vector Displayers. Vector displayers are used to display glyphs that represent vector field functions. The Vector Displayer node controls the display of vectors along the surface of a part. Vector displayers are created automatically when a vector scene is created. We can add a vector displayer to any scene. For this, open the Scenes node. Then, open the node of the chosen scene. Right-click on the Displayers node and select New Displayer. Then, select Vector. By default, the vector displayer will contain no parts after creation, and we must add parts to the displayer. Also, by default, a vector displayer uses velocity as the vector quantity. Now, we will see the Streamline Displayers. They are used to display derived streamline parts in a scene. We have to create such a part before. Remember that these displayers cannot be used to create streamlines. The Streamlines Displayer node controls the appearance of those streamlines. Streamline displayers are not created automatically through the creation of any scene and have to be added. To do this, open the Scenes node. Then, open the node of the chosen scene. Right-click on the Displayers node and select New Displayer, then select Streamline. The streamlines can be displayed using various styles, that is, lines, ribbons, and tubes. By default, the streamlines are displayed as lines. To change the style of the streamlines, expand the Scenes node and expand a scene which contains a streamline displayer. Expand the Displayers node and select the Streamline Displayer node. Set the style in the drop-down menu under the Mode property in the Properties window. The Tubes option displays the streamlines as cylinders with the diameter of the cylinder being governed by the Width property. The Ribbons mode displays the streamlines as flat surfaces with a width governed by the Width property. If either the Ribbon or Tube mode is used to display the streamlines, the size of the ribbons or tubes can be changed. For this, expand the Scenes node and expand a scene which contains a Streamline Displayer. Expand the Displayers node and select the Streamline Displayer node. Adjust the width of the ribbons or tubes using the Width property in the Properties window.